सब्सक्राइब कीजिए आयोटा इंस्टीट्यूट चैनल को और प्रेस कीजिए बेल आइकन को ताकि आपको मिल सके हमारा लेटेस्ट वीडियो सबसे पहले और ये बिल्कुल फ्री है।
Hello students, welcome to iOTA Institute Online. Today I am going to discuss about the hybridization. So what do you mean by hybridization? It is the mixing of orbital. Now let us assume that these are two atoms, and when these atoms will combine with each other, then they form a molecule. And this molecule is formed due to the sharing of electrons of these two atoms. Then actually the orbitals of atoms, that is atomic orbitals, are combining, due to which electrons are sharing with each other and hybrid orbital will form, and the phenomenon is known as hybridization. Now let us discuss one example. Carbon. As we know that atomic number of carbon is 6 and electronic configuration is 1s2, 2s2 and 2p2. Now number of valence electron present in carbon are 4, that is number of electrons present in outermost shell, and there are 2 electrons present in s orbital and 2 electrons in p orbital, that is 1 electron in px and 1 electron in py. Pz is vacant, and we know that more the number of bond, higher will be the stability. Now according to valence bond theory, total number of unpaired electrons will be equal to total number of bond formed. Okay, so according to valence bond theory, total number of unpaired electrons will equal to total number of bond formed, which means total number of bond formed by carbon are only 2 because it have 2 unpaired electron, but actually carbon can form 4 bonds. As we can see in CH4, it is forming 4 bond. So to explain this, how carbon can form 4 bond, we will introduce the concept of excited state. And what will happen in excited state? One of the paired electron will excite and take the vacant place. It means s orbital have paired electron and one of the p orbital is vacant, that is pz is vacant. So one electron of s orbital will jump and take the place of pz. So excited state is like this. There are 3 electrons in p orbital and 1 electron in s orbital, that is 2s orbital and 2p, px, py and pz. Now carbon can form 4 bonds because it have 4 unpaired electron, and this state is known as excited state. And this state is known as ground state. Okay, there is one more problem. The atomic number of hydrogen is 1 and electronic configuration is 1s1. So hydrogen have only s orbital, but carbon have s orbital as well as p orbital. Okay, so there are 2 different types of bond is forming. So 2 different bonds are formed. But experimentally it was seen that each carbon hydrogen 4 bonds are exactly identical to each other. So to explain this, we need the entirely concept which we called as a hybridization, that is mixing of orbital. So now you can take a screenshot. Now these are few points, let us discuss one by one. It is a mixing of atomic orbital to form a new orbital called hybrid orbital, and the phenomenon is called hybridization. It means that when two atomic orbital will get combined, then a new orbital will form, and that new orbital is called as hybrid orbital, and the phenomenon is called hybridization. Number of hybrid orbitals formed is equal to number of atomic orbital mixed. For example, H2. In this case, 2 hydrogen, this is one atom and this is one atom. When both atoms will get mixed, then they form a hybrid orbital. Similarly in CH4, how many hybrid orbitals are present in CH4? 1, 2, 3 and 4. So 4 hybrid orbital, that is 1CH, 2CH, 3CH and 4CH. Okay, it means one atom will combine with another atom, then they form a hybrid orbital, and number of hybrid orbitals formed is equal to number of atomic orbital mixed. Okay, hybrid orbitals are always formed sigma bond, so these all are sigma bond formed by two atoms. Hybrid orbitals have equal size, shape and energy. Shape of hybrid orbitals are unsymmetrical dumbbell. So as we know that dumbbell shape is this is symmetrical, but this is unsymmetrical, and this shape is for hybrid orbital. This is hybrid orbital shape and this is unsymmetrical dumbbell, and this point is known as node, where the probability of finding electron is 0. Okay, now you can take a screenshot. Let us discuss about Sp3, Sp2 and Sp hybridization. Let us start from Sp3 hybridization. In Sp3 hybridization, there is 1 electron in s orbital and 3 electrons present in p orbital. So there are 4 unpaired electrons, and according to valence bond theory, total number of unpaired electron is equal to total number of bond formed. So total number of bond formed in this case is 4. And how many atomic orbital are mixed? 4, because there are total number of 4 bonds are forming, and we know that number of hybrid orbital is equal to the total number of atomic orbital mixed. So hybrid orbital is also 4. Now number of sigma bond, there are 4 bonds, so total number of sigma bond is also 4. Okay, and now let us discuss about shape and geometry. There are 4 bonds. Let us take carbon and 4 bonds. 1, 2, 3, 4. Okay, so these are the hybrid orbitals. Sp3 hybrid orbitals. Okay, and the bond angle between two bonds is equal to 109.5 degree. So due to the bond angle 109.5 degree, the geometry is tetrahedral. Now this is the tetrahedral geometry. Okay, tetrahedral. This is the geometry and shape of sp3 is unsymmetrical dumbbell and geometry is tetrahedral because bond angle between two hybrid orbital is 109.5 degree. Okay. Now come to sp2 hybridization. In sp2 hybridization, one electron is present in s orbital and two electrons are present in p orbital. That is, one electron in s orbital and two electrons in p orbital. So total number of unpaired electrons in sp2 is 3, and according to valence bond theory, total number of unpaired electrons will be equal to total number of bond formed. So total number of bonds formed by sp2 hybridization is 3. So in this case 3 bond will be formed and total number of atomic orbital mixed is also 3, and we know that total number of atomic orbital mixed will be equal to the total number of hybrid orbitals, so it is also 3. Now number of sigma bonds, 3 bonds are forming, so number of sigma bond is 3. Now let us discuss about shape and geometry of sp2 hybridization. Shape is unsymmetrical dumbbell and there are three bonds. So 1, 2 and 3, and the bond angle between two hybrid orbital is 120 degree. 120 degree, and PZ is vacant, so it is perpendicular to the sp2 plane. Okay. Now let us discuss about the geometry. Carbon, this is geometry of sp2 hybridization. Now let us assume that this is sp2 plane and pz is perpendicular to the sp2 plane, so pz will placed here. Okay, so this is pz. So this is the position of pz which is perpendicular to this sp2 plane. Okay, so this is pz. Now the geometry is trigonal, planar, and bond angle is 120 degree. Okay. Now let us discuss sp hybridization. There is one electron in s orbital and one electron in p orbital. So total number of unpaired electrons are 2. So 2 bond will be formed and atomic orbital mixed are 2. So total number of hybrid orbital is also 2, and total number of sigma bond is 2 because 2 bonds are forming. Now let us discuss about shape and geometry. The shape is unsymmetrical dumbbell. 2 bonds are forming, so there are 2 hybrid orbitals and the bond angle between 2 hybrid orbitals are 180 degree. Okay, and the geometry is linear. Linear geometry. Now let us assume that these are 2 hybrid orbitals and the bond angle is 180 degrees. So this is linear geometry. Now in sp2 hybridization, 3 hybrid orbitals are forming and the bond angle between 2 hybrid orbitals are 120 degrees. Similarly between these 2 hybrid orbitals and similarly between these 2 hybrid orbitals, and this is 3 hybrid orbitals and pz is placed perpendicular to the sp2 plane. These 3 are present in the sp2 plane and this is PZ which is placed perpendicular to the sp2 plane. Okay, so the geometry is trigonal planar. Now in sp3 hybridization, this is the geometry of sp3 hybridization. The bond angle between two hybrid orbitals are 109.5 degree, and this is like this. Okay, so this is sp3 hybridization geometry, that is tetrahedral. Now you can take a screenshot. Let us discuss the hybridization of chlorine. As we know that atomic number of chlorine is 17 and this is electronic configuration, and number of valence electron present in chlorine are 7, that is electrons present in outermost shell are 7. So we will consider only these electrons, and according to valence bond theory, total number of unpaired electron will be equal to total number of bond formed. So there is only one unpaired electron present in chlorine, so total number of bond formed between Cl2 is 1. And we have discussed that number of atomic orbital mixed is equal to total number of hybrid orbitals. So here is only one atomic orbital is combining, so total number of hybrid orbital is 1, and that is p. But till now we have discussed about sp, sp2 and sp3 hybridization. We haven't discussed about p hybridization. In this case, as we know that chlorine have lone pair, that is 1, 2, 3, 4, 5, 6 and 7. 7 electrons present in outermost shell. So, and one of the electron of chlorine will form bond. Okay, and remaining 6 electrons will also take part in the hybridization. Okay, so these 6 electrons will take part in the hybridization. Now let us discuss the hybridization S, Px, Py and Pz. So hybridization is sp3, not P. It is sp3. Okay, so this is the hybridization of chlorine. In case of lone pair present in atom, that lone pair will also take part in the hybridization. So we get hybridization of chlorine as sp3. Okay, so now you can take a screenshot. Let us discuss the hybridization for boron. As we know that atomic number of boron is 5 and electronic configuration is 1s2, 2s2 and 2p1. And number of valence electrons present in boron are 3, that is electrons present in outermost shell, that is 3, and there are 2 electrons present in 2s and 1 electron present in 2p. It means py and pz are vacant, so one of the electron from 2s will get excited and take the place of py, because after px, py is vacant. So one of the electron from 2s will get excited and take the place of py. Now there is 2 electrons in p orbital and 1 electron in s orbital. So now there are 3 unpaired electrons. It means 3 bonds can be formed by boron, and total number of hybrid orbital is 3, because there are 3 number of atomic orbital which are combining with each other. So boron have 3 bond and it will combine with chlorine, that is BCl3 and 1s and 2p, 1s and 2p. So the hybridization is sp2 and hybrid orbitals are 3. So it is 3sp2, that is one of the electron of chlorine and one of the electron of boron will get mixed, and the geometry is trigonal planar and pz is vacant. This is vacant pz which is perpendicular to the sp2 plane. Okay, so this is the trigonal planar geometry. Okay, so now hybridization is sp2. Now let us discuss the hybridization of beryllium. As we know that atomic number of beryllium is 4 and electronic configuration 1s2 2s2, and there are 0 electrons present in p orbital. Now as we know that there are 2 electrons present in outermost shell, that is number of valence electron of beryllium is 2. So one of the electron from 2s will get excited and take the place of p orbital, and px is vacant, so one electron will jump and take the place of px. So px, py and pz. So now this is excited state and this is ground state. So there are 2 unpaired electrons, that is one in s and one electron in p. And according to valence bond theory, total number of unpaired electron is equal to total number of bond formed. So BeCl2. In case of BeCl2, total number of bond formed by beryllium is 2. And the bond angle between 2 hybrid orbital are 180 degree. Okay, that is like this, 1 2, and chlorine 1. Okay, so one electron of beryllium will combine with one electron of chlorine, and similarly in this case one electron of beryllium will combine with one electron of chlorine and they form a sigma bond. Okay, these are the sigma bonds and the shape is unsymmetrical dumbbell, and bond angle between these 2 hybrid orbitals are 180 degree. And as we know that if the bond angle is 180 degree, then the geometry is linear. So this is linear geometry. Okay, and hybridization is sp, and total number of hybrid orbital are 2, and total number of sigma bonds are 2. Okay, so now you can take a screenshot.
सब्सक्राइब कीजिए आयोटा इंस्टीट्यूट चैनल को और प्रेस कीजिए बेल आइकन को ताकि आपको मिल सके हमारा लेटेस्ट वीडियो सबसे पहले, और ये बिल्कुल फ्री है।